Good morning, class. In our last class, we have derived Nernst equation, and I told you that for our next classes we'll be doing the numerical based on it. So today we'll be doing the numerical based on the Nernst equation. This equation is very important as well as the numerical also. Every year in your ISC board examinations, one questions we find from this Nernst equation. So you need to be very careful while understanding this Nernst equation. Now, we need to keep in mind the formula that we are going to use. So the first formula that we are going to use is EMF of the cell. How we can calculate the EMF of the cell, that is electromotive force of the cell. It is given by the formula E cell equals to ER minus EL. ER means electrode potential at cathode, that is at right, and minus electrode potential at anode, that is left. Okay, so it is given by this formula. Next we have got the formula calculation of cell potential using Nernst equation. So this is the Nernst equation that we have derived in the last class. So wherever E cell is given by E cathode minus E anode, this is the EMF, or we can say the standard electrode potential, minus 0.0591 divided by n. N is the number of electrons that get lost or gained, log 10 in the numerator products by reactants. So this is the formula for Nernst equation. We'll be using this formula in calculation of cell potential. Now let us see the numerical, how we can solve the numerical. So I have taken the question that has come in the year ISC 1998 to make you understand how we are using the equations. So the question is, the standard reduction potential of copper and zinc electrodes are plus 0.350 volt and minus 0.763 volt. Okay, for the cell, that means the cell representation is given zinc slash Zn2 plus, that means zinc dot is installed in, is dipped in zinc sulfate solution which has got the concentration of 1 molar. Double line, that means there is a salt bridge between it, and on the right hand side we have got copper dipped in copper sulfate solution which has also 1 molar concentration. And now you are asked to find out, write down the cell reaction. You need to write down the cell reaction. And number 2, calculate the EMF of the cell. Okay, calculate the EMF of the cell. And next we have got question number 3 is the cell reaction spontaneous or not? Okay, let us see how we can solve. So first what you are going to do is, we'll write down the cell reaction. Okay, what is the cell reaction? Now from the representation that is given above, okay, the cell representation. So as we know, on the left hand side of the salt bridge, oxidation process takes place, and on the right hand side, reduction process. Okay, now let us see. So oxidation means loss of electrons. So from Zn to Zn2 plus there is loss of 2 electron. So Zn minus 2 electron will give you Zn2 plus, that is oxidation. Okay, on the right hand side we have got copper ion converting into copper. So copper ion gains 2 electron and it gives you copper, that is the reduction. Okay, now when you combine these two reaction, okay, now when we combine these two reaction, I'm talking about this and this one. Okay, so when you combine these two reaction, what will happen? This 2 electron will get cancelled, and on the left hand side you'll have zinc plus Cu2 plus, zinc plus Cu2 plus, and then we have got on the right hand side Zn2 plus Cu. So this is the cell reaction. Okay, this is the cell reaction. After that, question number 2 is calculate the EMF of the cell. So the formula that we have seen before, E cell equals to E reduction minus E reduction at anode, E cathode minus E anode, and we have seen that ER minus EL. Okay, so at cathode, at cathode. So we have already given in the question the standard reduction potential of copper and zinc. So for copper is 0.350. Now over here, the value for E reduction at cathode what will take place? Reduction process. So it will be for copper, so the value will be 0.350 volt minus E anode. So the anode value is minus 0.763. Now since minus minus become plus, it will get added and the E cell value will come as 1.13 volt. Okay, 1.13 volt. Now since this E cell value is coming positive, the cell reaction is spontaneous. Okay, if the E cell value comes as negative, the cell reaction is not spontaneous. So we have solved this equation. Okay, next. Now assignment for you. Assignment 8. Question number 1 is, this question has come in the year ISC 2005. For the cell reaction zinc slash Zn2, A means concentration is taken as 1 molar, double slash, that is salt bridge, copper 2 and copper. Given that, what is given? This one is given, E Zn2 Zn plus. This is the oxidation potential. How to know? Because there is a loss of electron. So 0.76 volt and E copper 2. This is the reduction potential. One is oxidation, other is reduction. Right, the cell reaction question is, and number 2 is calculate the EMF and free energy change at 298 Kelvin involved in the cell. F value is given, that is Faraday constant. Okay, now EMF we know the formula. How to know? With cell reaction also know. Free energy is given by this formula. Free energy is given by this formula. Del G equals to minus N F E. Okay, you will use this formula. Okay, N E del G equals to minus N F E. Okay, now over here, N is the number of electron if value is given, and E you'll calculate from the EMF. That will be okay. So you can calculate the free energy. This the second question has come in the year ISC 2007. Calculate E cell at 25 degrees Celsius for the reaction Zn plus Zn2 plus 0.20. This is the concentration of that solution, and Zn2 plus to copper. Okay, the cell reaction is given, and you need to write down the E cell, and what else value is given? The reduction potential is given of copper and zinc. So you solve this equation and send in my mail.